To the nearest degree, which values of theta satisfy the equation tan theta equals negative 4 over 3? So this starts off looking like a grade 10 trig question. How do you solve for theta? You would use tan inverse. The difference is that there's a negative, and you never had negatives involved in any grade 10 trig, because you don't draw triangles with negative sides. You always draw triangles with positive sides. So what happens in grade 11 is the idea of the cast rule comes into play. And if tan is negative, we're going to use the cast rule to find out which quadrants this is in. If tan is negative, which quadrants would that be in? C or S. So in other words, quadrant 2 or quadrant 4. So what I could do is I could draw it in quadrant 2. If I drew it in quadrant 2 and I made a triangle with my reference angle, if tan is 4 over 3, my reference angle says the opposite side has to be 4, the adjacent side has to be 3. If I drew it in quadrant 4, and I made a triangle back to my x-axis so I could label my reference angle, tan is negative 4 over 3. That means my opposite side would be 4, my adjacent side would be 3. Then once we've drawn those triangles, we can go back to our grade 10 SOHCAHTOA and find that reference angle. Because if we have a triangle drawn, we know how to find angles in triangles. With reference angles, we always use positive values. And so I would write tan of my reference angle is equal to opposite over adjacent, 4 over 3. Because it's an actual triangle, and with reference angles, because we're working with an actual triangle, we're using all positive values. You would go to your calculator, go tan inverse of 4 over 3, 53.1 to the nearest degree. It says to the nearest degree, so I'll write it out. We would type in tan inverse of 4 over 3 to find our reference angle, and our reference angle to the nearest degree is 53 degrees. So you can now go to your diagram and say, I know this angle is 53 degrees here. I know this angle is 53 degrees there. If we read the question, though, the question didn't say, find the reference angle. It said, find which values of theta. And when it's asking for values of theta, theta's in standard position. Standard position starts on the positive x-axis, and so here it would be this angle. This is one possible answer for theta. And in quadrant 4, if I started here and went to my angle, that would be my theta. So can you see that we're going to get two different answers for theta? We're going to get one answer in quadrant 2 and one answer in quadrant 4. Now what will those answers be? How would I figure out what this one in quadrant 2 is? 180 minus 53. It's going to equal 180 degrees minus 53, 127 degrees. What about this one? Makes sense that you would take 360 degrees and minus 53? 307 degrees. Yes? So does it come up as like a smaller decimal? Is your calculator in degrees or is it in radians? So if you've got your calculator and you're getting a different answer than 53 degrees, hit your mode button, and if it's highlighted on radian, move it over to degree and push enter. And then you'll be able to get the correct answer in degrees. You don't need to put it into radians until next year. Okay, questions for practice on this one. 14, 15, 16, and 19. And for question number 14, they want you to do it without a calculator, so you can use the chart on page 444 to figure it out. Or you can use your graphs for sine and cos to figure them out. Oh, I'm still recording.